In this chapter, we're going to get to study some triangles. Triangles are classified by their angles and sides. Classified means that's how they get their names. So let's take a look at this topic. So first of all, what we need to know about triangles. A triangle is a figure that is formed by three non-collinear points. Those points join three segments. That's where triangles get their three sides and three corners. Keep in mind, the points have to be non-collinear. If the points are collinear, then they just make a line. They don't make a triangle. When they're non-collinear, they scatter, and I can connect any 3 points and make a triangle. A triangle is classified by angles and sides. The angles are the corners that we've learned about, and sides are the lines, or I say like the sticks that connect them together. When we name a triangle for its angles, it will get one of these three names. If all the angles are less than 90, we say it is an acute triangle. If there is a 90-degree angle somewhere in the picture, we call it a right triangle. If there's an obtuse angle somewhere in the picture, we say it's an obtuse triangle. We can also classify triangles for their sides. Basically, how many are the same? So in this picture, side names are equilateral. Equilateral are when all three angles and all three sides are the same. Isosceles. Isosceles triangles are ones that have two angles or two sides that are the same. A scalene triangle have no angles that match and no sides that match. Everything is different. That's the way I kind of call this the 3-2-1 method. For equilateral, 3 are the same, 2 are the same for isosceles, and every one is different for scalene. When we name triangles, they always get an angle name and a side name. So we pick one from each chart that we just looked at. So for instance, this triangle that we have down on the left has sides that are 5 and 5 and 7.5. And we notice that there is a 90-degree corner. So when we name this triangle, we pick one name from each chart. So this triangle would be a right isosceles. It has a 90-degree corner, so it is a right triangle. Two sides are the same, so it is isosceles. That's why we call it a right isosceles. Let's look at another one. Here's a new triangle. The sides are 5, 7, and 9, so they're all different. Look at the angles. The angles are all different also. And we notice that there is one obtuse angle there at the top. So this triangle would be an obtuse scalene triangle. Obtuse because it has an obtuse corner, and then scalene because all the sides are different. That's how we name triangles. They always get two names, one from each chart. Okay, let's learn about parts of a triangle. The vertex of a triangle are the points. Okay? It's the part where the sticks come together. Those are vertex, or if there's more than one, you call them vertices. That's the plural, vertices. Adjacent sides are two sides that share a corner. Two sides that come together at the same location, they're called adjacent. The other side would be called the opposite side. So let's look at a picture. Here we have a triangle, and they're drawing our attention to the 35-degree angle at corner B. Number 1 says name all the vertices. So notice I've labeled each corner as a vertex. Number 2 says find the adjacent sides to the given angle. Well, the given angle is the 35. So adjacent sides would be the ones that share that corner. So the two lines that come together at that point would be adjacent to one another. Number 3 says find the opposite side of the given angle. So the side that does not touch the 35 degrees would be called opposite. It's away from. So adjacent are the ones that touch it, and opposite is the one away from it. There are some special names for isosceles triangles we need to look at. Remember, isosceles is when two sides and two angles are the same. First of all, an isosceles triangle will have something called a base. A base is the side that's different than the other two. Remember, isosceles have two matching sides. So the third one that's different, that's called the base. The base doesn't have to be at the bottom. Don't let that trick you. The base can be anywhere. It's just the one side that's different. The legs of the triangle are the sides that are identical. So the two matching sides are called legs. The one that's different is the base. In this case, the vertex is the point where the legs come together. So the two matching sides where they touch each other, that's going to be called the vertex. The other two angles we call base angles. So the base is the different side. Its endpoints are base angles. Let's take a look. Here's two triangles. The legs are the sides that match each other. The base is the side that's different. The vertex is where the legs would touch each other. So if you notice, you extend those green lines where they would touch each other, that's the vertex. And then if I know where the base is, its endpoints become base angles. Something kind of cool happens with isosceles triangles, by the way. The base angles will always be the same size. So even if they're not written in the picture, you will know that those angles are identical. And the base angles are always the angles across from the matching sides. So I put a little crisscross in kind of a purple color there. So the base angles are the one away from a leg. Now, right triangles have some special parts of their own. Right triangles will have something called a hypotenuse. A hypotenuse is the longest side, and it's the one opposite the right angle, or the one that does not touch the right angle. You should always find this in a picture first. Find your right angle, and the side that does not touch it is the hypotenuse. Find that first. The other two sides are called legs. So it's basically the ones that are not the hypotenuse. It's okay for those to touch the right angle. The right angle is the 90-degree corner. The other two angles will always be acute. Okay, so even though there's two acute angles on a right triangle, we still call it right because it is a 90-degree angle. Let's take a look. First step, I found the hypotenuse. I find my 90-degree corner and I go away from it. That is the hypotenuse. So sometimes it's hard to tell in a picture which one's the hypotenuse, which one's longest. It's always the one away from the 90. Find that first. First step when using right triangles, always find the hypotenuse first. The other two are called legs. They might be the same length, they might be different lengths from each other. It doesn't matter, but they're the two sides that come together at the 90-degree corner. The right angle is the 90-degree box corner. The other two will be acute angles.